Okay, here is our fraction review. Let's take a look at what we have here. Let's just take a look at this fraction here. We have 3/4. Again, I always talk about the fact that when I am first looking at a fraction, I always think about the denominator first, because that tells me what the whole is cut up into. I don't know what the whole is yet, but I do know that it's cut up into 4 pieces. And that is, of course, the denominator. The number in the bottom of the fraction, it tells you how many pieces that the whole was cut up into. The pizza was cut up into 4 pieces, perhaps. Then I take a look at next the top part, which is the numerator. It's really, how many of those pieces are you talking about? The other thing I look at is how close these two numbers are. 3 and 4 are pretty close together. So that kind of tells me that this is pretty close to a 1. It's going to be almost the whole. Not quite, of course, 1 piece is missing. If there's a big difference between the top and the bottom, I kind of know that maybe that is not close to 1. It's something else, another number. Here is some shapes that you may have to cut up and show 1/3. How do you do that with a triangle? It's kind of a tough one, but usually I would just kind of maybe divide it up like a peace sign, and then I could show in, I could then color in 2/3 this way. How would you show 5/8? Well, cut something in half, I would go this way. Then maybe I'd go this way. And now I need to cut the halves in half, or the quarters in half, sorry. There's my 1/8, and then I would color in 5/8 for that. Let's talk about putting fractions in order. If they have the same denominator, this is the whole cut up into 11 pieces, then you could just order them by the numerator. So that is, in this case, the 2 is the lowest and the 9 is the most. I want to talk about, so if it's the same denominator, all you have to do is look at the numerators. But here's something kind of funky. What if you have the same numerator? What if the numerator is the same? How do you put that in order? Well, it turns out that when you are working with fractions that are all the same numerator, the bigger the denominator, that means the smaller it is. So you could have 3 pieces of the pizza, but the pizza was divided up into 12 pieces. Or you could have 3 pieces of the pizza and the pizza was divided up into 3 pieces. That means you ate the whole pizza. So it's kind of interesting that if you have the same numerator, the smaller denominator is actually the most, and the larger denominator is actually the least. Okay, the sweet spot for fractions really are between 0 and 1. But some fractions or some numbers might go beyond that. When that happens, we end up with what we call an improper fraction. In this case, 3/2, the whole was divided up into 2 pieces, but you have 3 pieces. That's actually more than 1. So what you would do is, okay, teachers love using pattern blocks for their fractions because they can kind of interact together and you can demonstrate different kinds fractions with them. But one thing that's really common is the idea of the whole. What is the whole? The whole in this kind of fraction is always one hexagon. So one of the yellow hexagons is really the whole. So your idea at first, or your job at first, is to figure out how many different shapes would be fitting on top of that. It's almost like you're cutting up that hexagon into different shapes. With triangles, I can get 6 on top of there. So it's really like having the hexagon cut up into 6. And this guy can have 2 cut up on there. So that was really 2 on there. So it's like I'm cutting in 2. And with blue rhombuses, you can get 3 on there, which is really how dividing that up into 3 pieces. So in this diagram, I have 1 out of 6 of the hexagon filled. I have a half filled here, and I have 1/3 here. Now this can be a confusing diagram over here. Although I have got different hexagons. In fact, I have 3 hexagons on here. I always have to kind of assume what is the whole. Unless I'm told otherwise, the whole is always going to be 1 hexagon. So this is also going to be still out of 6 because I'm using triangles and 6 triangles go on there. So if I have 6 as the whole, or 6 pieces, now how many green triangles do I have altogether? I've got 6 here, another 6 here, and 2 there. 6 and 6 is 12, plus 2. That really makes 14 out of 6 is what this shows. But I can also do this as a mixed number and say that I have 2 full hexagon, and then I've got 2 6 left over. Okay, one other thing that you might have to worry about is talking about equivalent fractions. Look at that, it's doing it by itself. Equivalent fractions are fractions that look different. They have different numbers, but they have the same value. They have the same value. And we're going to talk about some strategies you have to make equivalent fractions. Now, when I have a fraction, if I have a fraction like 1/2, if I multiply something on top and multiply something on the bottom, let's say 2 by 2, I'll end up with 2/4. Well, that is also a half. So one thing you can do is you can multiply a fraction top and bottom to get an equivalent fraction. Let's go the other way around. Let's say you had, let's say I had 8/16. Let's say I divide this by 2 and divide that by 2. That would give me 4/8. 4/8 is the same as 8/16. I could keep dividing 2 and 4/8. I could keep dividing 4/8. That would become 2/4. Keep going, dividing by 2, and that would give me 1/2. Sorry, 1/2. These are all equivalent fractions. So if I'm talking about strategies for doing equivalent, to make equivalent fractions, I could say multiply the top and the bottom, or divide the top and the bottom. But you cannot add or subtract. Do not add or subtract. That is not the way you go. Boom, 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 boom. So let's do some equivalent fractions, and I'm going to use the strategy of multiplying. So I'm going to multiply the top 1/2 here by 2, and I'm going to get 2 on the top and 4 on the bottom. Now I'm going to multiply this time by 3, and I'm going to get 6/12. Those are all equivalent fractions. I can double the top again, 10/12. Yes, and I can double that again, and I can say 20/24. So another strategy would just be double or triple. So 1/3, let's triple it, can become 3/9. Triple again, I can get 9/27. Those all equal 1/3. And I'll stop there. The other thing for grade 4s and 5s that you have to know about is converting fractions into decimal. when I write a number like 7.96, this, of course, is the ones. Here are the tenths, and here are the hundredths. Sorry. Okay, so how would that work over here? Well, I've got a whole here that's cut up into 10 different pieces. So this is really, in terms of fraction, it's out of 10, and there's 3 of them. And so that would be turned into 0. Now here's where the tenths, how many tenths? 3, 0.3. This one is 0.8. The fraction was 8 over 10, or 8 tenths. Yikes. Sorry, boys and girls. Okay, here's a few more that you might have to worry about. This time we're talking about 100. So it's how many spaces are colored in over 100. To make it interesting, let's just add a couple more here. Let's go to right here. Okay, so now if I was doing this and I was doing the fraction, I would say that this is, let's see, there is 10, 20, 30, 40, 50, 60, 70, 71, 2, 3, 4. So there's 74 colored in out of 100, and that equals 0.74. Now this one here is one of those tougher ones where really this is still the whole. So the whole is really still divided up over 10, but how many are colored in? I've got 10, I've got 20, and then I've got 8. So it's really 28 over 10. So that really equals, whoops, boo-boo. That really equals 2 wholes and 8 over 10. So here's one whole here. Here's one whole here. And finally over here you've got 8 over 10 left over. Whoops, what did I do there? Okay, here's a really interesting page for the grade 5s only, grade 5 only. I'm going to ask you to take this fraction, convert it into a tenth or a hundredth, and finally end up with a decimal over here. Now, when we're doing fractions, if we can get it to be something over 10 or something over 100, then I know that I can make a decimal easily here or easily here. So that is our job. Get it to something over 10 and something over 100. So when I'm doing 1/2, I have 1/2, and I think that is an easy number to convert into something over 10 because I can multiply that by 5 here and 5 there, and that's 5 over 10. So that means the decimal will be 0.5. Here's over 3, 3/5. Again, I can change a 5 into 10 by multiplying quite easily. I'm going to multiply those both by 2, and I'm going to get 10 on the bottom, 6 on the top, and that's 0.6. I'm going to leave this one alone, and I'm going to jump down to a more obvious one down here about the 50. Now I've got 23 over 50. I really can't easily make that into something over 10. I could divide, but the numerator won't easily divide by 5. So I'm really going to have to jump this one over to 100. And that is times 2. So I multiply this by 2, and I get 46 over 100, 0.46. Again, this one is 16 over 20. To make this something over 100, something over 100, I need to multiply that by 5. So this gets multiplied by 5, and I end up with 80. And I get 0.80. Because we have it over 100, I would go and put that extra decimal in here. I'll go along for the ride. Again, 6 over 25. I'm going to make this over 100 by multiply the 25 by 4. That means this gets multiplied by 4, and that gives me 24 out of 100, 0.24. Now, 4 is the one that I usually kind of leave to the end because it's a 4 in the denominator, it looks really like I should be going to the 10. But in order to do that, to turn a 4 into a 10, I got to multiply by 2.5, which is going to give me kind of a funky decimal. So instead, although 4 is less than 10, it's the only one that really we end up going to 100. Oh, go away. Sorry, boys and girls. So Here we are. So what I would do is I have 3/4, and instead of a 10, I want to make that, turn it into something over 100. How many times do I have times 4 to get to 100? I have to times it by 25. So that means this is times 25, and that will give you my 75 over 100, and I get 0.75. This is quite a lot going on. If you understand what's going on here, you are doing awesome. Good luck. There will be some questions about this on the test. Hey, boys and girls, this is the end of my video. Write your name in the comment to show me that you've done it, and you can print out the blank sheet if you want to go over it yourself. I'll talk to you later. Bye-bye.